Hello there, CC friends. We're going to talk just a little bit more about exponentiation. We already did 3 videos that kind of covered the first 4 pages. But looking forward, much of what is in this unit is all covered in that. It's just kind of like, you're learning the laws of exponents, logarithms, roots, and roots are really just exponents. And then we take it and we advance further and further and further. So I figured I would just touch on a few more concepts in this video. And then, again, post those comments and questions if you have any, and I'll happily discuss more things. So the first thing I touched on in one of my videos, but I just wanted to talk a little more about, is fractional exponents. So first of all, if we have a square root is the only root that there's going to be no number listed out front. It is assumed, because it's such a common root, that it is a square root. But remember, there's this unspoken 2 out front that you might see, especially in the lower levels of the math map, but you're not necessarily going to see. They actually, they've done a pretty good job of putting it there, so I will correct myself on that as I'm looking at it. Sometimes it's there, sometimes it's not. So just remember that that is assumed to be a square root if there's no 2 there. So if I was to rewrite this as a fractional exponent, kind of like there's assumed to be a 2 there, there's assumed to be a 1 here. Every single number, and I always teach my kids that 1s are like the magic number, because 1s can kind of pop up anywhere. It's like if you have a whole number and I'm trying to explain to them how this times 1/2 only multiplies to the numerator, the top number, I always tell them, well, there's always a 1 underneath. We just don't write it, because 4 divided by 1 is still 4. And then they can see that process of the tops are multiplied, the bottoms are multiplied, because a lot of kids would want to do 4 times 1 and then 4 times 2, and it would give us the wrong answer. So it's the same concept here. If it's any number that doesn't have an exponent, has an exponent of 1, because it's to the power of 1. So we have the 4 to the 1 root 2. Okay, so what does that mean if we were to convert this into a fractional exponent? I teach that the number up top with the number, because they got to associate it's up. Okay, so it's up here with the number, that's the numerator, or the top number of the fractional exponent. And then the number that's down here in front is the denominator of the fractional exponent. And that's how we would write it. It's 4 to the 1/2 is the same as the square root of 4. So if we picked a little bit of a bigger number here, and I said x to the 3rd 4th root, okay, now we're throwing some x's in there. So x to the 3rd 4th root is the same as saying x. Here's that upper number, so the upper part of my numerator, or my fractional exponent, the numerator is going to be 3, and then the denominator is going to be 4. So have fun playing with this, and again, I'll review in here, just in case maybe you popped on this video but didn't see the others. You have your negative exponents too. So let's do one more and say, okay, we have to simplify this thing. Let's do a nice hard one. We'll say x, y to the -2, and z to the 4th all over 4. Let's just, or to the root of 4. Let's have some fun with that, okay? So what do we do with it? So the first thing that, you could flip this first, because remember, negative exponents, just to review that, 4 to the -2 is equal to 1 over 4 to the +2. It just flips the side of the fraction it's on. So this is 1 over 16. So we could do that first and then carry the root over. I usually like to just get rid of the radical sign first. So you're really just changing notation when you go from here to here. You're changing the notation so it's something easier to work with. So when we do that, this is going to become, it distributes, because remember this rule, x to the 2 well, we'll say x to the 2, we multiply those exponents. This becomes x to the 4. So it's that same concept here. This number is going to go into the fractional exponent of the x, the y, and the z. It doesn't just go to the front number. So this is going to be x to the 1/4 times y to the negative 2/4 times z, making sure it's still on the screen, z to the 4/4. And then, like everything in math, we have to simplify it. That's not going to be enough. So this, we can't do anything with it. So we just leave it. X to the 1/4. But now this has a negative exponent, and we can simplify the fraction. So what we're going to do is turn this whole thing into a fraction. So we're going to bring that down. So it's going to be y. I'll keep it 2/4 just for a second. Y to the 2/4 times z, and I'm going to still keep it 4/4 just because I'm showing 3 steps. We change the notation. Now we eliminated the negative exponent, and the final step is we're going to simplify the exponents. So we have x to the 1/4. We have z just to the 1 because 4/4 is 1. And then here, 2 divided by 4, that's going to simplify down to 1/2. So y to the 1/2. And we're done. So there's a little bit of fun math for you. And then the other thing I was going to talk about is you've probably noticed the laws of logs. So the laws of logs, we talked about the change of base formula on one of my videos. So the law of logs is relating to your exponent rule. So I'm just going to draw a parallel real quick. It might even do it in the book. I looked ahead. I didn't see it in here, but it might. But let's say if I had x to the a times x to the b, okay? Now this is different than taking it to a higher power. It's the same base, but they're multiplied. We add the exponents, x to the a plus b. Whenever you see stuff like that, it's x to the a plus b, or whatever it might be. These are just kind of representing general rules because it could be confusing when sometimes you see numbers, sometimes you see letters. So just know that those are representing your general rules when you see those things listed out in here. So with that, we would have, if we had a log of a log base x of a times, wait, I have to think backwards here because I'm making this up on the fly. If I had, I don't like that I used x. I'm going to correct myself here. Okay, so let's just do an example in the book, and then it makes it a little bit easier. So if I go to page 6, I have these problems here where I have log base 2 of 8 times 64. Okay, now you'll see it simplifies it. It says simplify the logs, and this becomes log base 2 of 8 plus log base 2 of 64. So we're going to actually work backwards instead of doing general math rules. Sometimes you come from a teaching background, and the traditional style is you teach the rule and then you do an example problem. But I think when we see this kind of stuff, sometimes it's easier to actually see the example and why it works first and know that the rule is generalized for any scenario. So remember, we have log base 2 of 8 plus log base 2 of 64. So how did that happen? Well, let's go back to here and say 2 to the, in general, 2 to the, let's go, stay with A's and B's. 2 to the A times 2 to the b. So now we're going to generalize and say, okay, any two exponents here with that same base, this becomes 2 to the a plus b, right? Okay, so we can see here if these logs are representing exponents, because it's another way of actually writing the exponent, then this works. Because we're saying, okay, if that base is 2, just like in here, then the multiplication turns into addition. Okay, so it's related to that exponential law. Likewise, let's do the example that's, we have another one where we have a log base 2 of 64 over 8. And then it shows us, oh, this becomes log base 2 of 64 minus log base 2 of 8. Okay, so this little magic trick happens too. And we're like, what just happened there? So this relates back to if I had a base 2 and it's a divided by 2 to the b. Okay, this is the same as, again, we go back to the negative exponent rule. This is truly a negative b if I flip it upward. So this is the same as saying 2 to the a times 2 to the negative b. So what happens? It just subtracts. So this becomes 2 to the a minus b. And that's why that law exists. Then there's one more, and it is the exponent law. So let's do log base 2 of 8 to the third. And all of a sudden, it shows us this becomes 3 times log base 2 of 8. And then it proceeds to simplify. But how in the world did that happen? Okay, so we would say that 2 to the a power to the b power, again, we're just generalizing here now. This is that multiplication rule. This becomes 2 to the ab. Okay, so again, this thing represents an exponent. So it's exponent to another exponent. So it turns into multiplication. And that's how that third law of logs works. So that's like an FYI. And again, don't stress over this. This is very advanced math, some of these things, but I love how they're showing the patterns in this, and it's just beautifully done. I also love this unit because there's a lot of review all mixed in. If you feel lost at all, highlight the things your student does know and then explore the things your student doesn't know and just play with some of the more basic problems. And then I comes in and we have the imaginary number back for many of these problems. Don't forget, I is square root negative 1. I squared equals negative 1. I cubed equals negative I, and I to the fourth equals 1. And don't be afraid to let them compute that again if they forgot it. This is in my video, What is I? I recorded that too, where I explain this a little more. But this is very important to remember as you're working through these, because sometimes the answer will be different, and you'll say, "What did I do wrong?" Well, there you have it. That's just a very those are the principles of I and its cycles, and then the higher powers keep circling back around because I to the fifth goes back to I again. So the last thing I was going to say is, if you are exploring using a calculator, again, I recommend a scientific calculator at this point, not a graphing, or at least don't let them be graphing. Well, we're not there yet anyway, but once you hit the graphs, it's really important that they understand the graphs and learn that, you can't just plug it in a calculator and see what it looks like. You also want to know. And this curriculum I'm totally at peace with is going to show us the why and not just how to put it in. But at least a scientific calculator that has log buttons. So you need to teach them what these two buttons mean, because at some point you're going to have to calculate these logarithms, and we can't always figure out 2 to the what equals 17. You cannot figure that out in your head. So you're going to have to use the logarithm. You're going to have to use the change of base formula that we talked about in the other video. These are general. These are very often used, kind of like square root, we assume, when we don't see the 2. This is the same as a log base 10. This is the same as a log of base e. It's called the natural log. Common log, natural log. Okay, natural log, what is e? E is an irrational number like pi. Okay, and it actually has it. Let me give you the page number. I saw it in here. Um, it pops up, it probably comes up before this, but there's a part, and by the way, they have a little calculator picture where you'll need a calculator. It shows us e squared. So e squared, they round to approximately 2.718. It's called Euler's number. That's why it's an E. And it is going to come up everywhere in higher levels of math and calculus. It's a really cool number. So, but anyway, that's what E is. It is a set number. It's not, it continues on forever. It's irrational. We can't represent it by fractions. We can approximate it many different ways, but just know that's what E is. Actually, page 16, check it out. It shows you E, it shows you phi, which is this guy. I'm terrible with the Greek letters, but I know what they mean. So we have this one, and this is equal to 1.618. This is called, also known as the golden ratio. It's all connected to Fibonacci sequences. It's really cool. So, check out some fun videos on that. I did a presentation once all about like Fibonacci numbers in nature, and it's just a cool number, but there's so much in that. This one's going to come up less frequent in your more traditional math, but it will come up. And so it's just good to know, what is it. Just, you don't have to memorize it naturally. These go on forever, just like pi. And this one we've always kind of taught them from a young age. 3.14, they round it one more, it's 3.142. Okay, so that's what these random letters are that are popping up, Greek and English. So hopefully this helps. And again, reach out if you have more questions. And I hope you're enjoying your journey. So thank you for tuning in. We'll see you next time.